All right, we're moving on to the bonus section of Chapter 12, which is Hero's Formula. And this is an extra section that we do in 4 level, and the idea here is that it's a nice little formula that you can use. I know that the years that I've taught 2, 3, 4, which is the Algebra 2 class that comes after this geometry class, I know that kids have used Hero's formula in the past. So it's a useful formula. It's something that you should know. The formula basically allows you to take a triangle with sides A, B, and C, and if I give you those 3 sides, you can find the area of that triangle. It's a nice little formula. So the formula works like this. The area of the triangle is equal to the square root of S, which is the semi-perimeter. Just like a semicircle is half the circle, semi-perimeter is half of the perimeter of the triangle. So it's S times S minus A, which is the first side of the triangle, times S minus B, times S minus C. And once you plug that into that formula, you can get the area of the triangle, any triangle where you know the 3 sides of the triangle. Now, if you're curious where that comes from, there's a nice little derivation here. And the derivation looks something like this. Now, we normally in 4 level would go through this entire derivation. It would take about 15-20 minutes to go through the derivation. I am not going to go through that on this video here, mostly because I think if I did, I feel like a lot of you would just fast forward through the video. But for those of you who are curious about this derivation, here's what the derivation looks like. I'm going to go through it, kind of scroll through it slowly, and you can always slow it down on your video. But that is what the derivation looks like. You will do stuff like this next year in Algebra 2, so be ready for that. But as you can see at the very bottom of the derivation here, you have Hero's formula. So getting back to the worksheet, there's kind of an extra formula here that's related to Hero's formula. It's called Brahmagupta's formula. I love saying that word, Brahmagupta. He was a Hindu mathematician from a long time ago. And what Brahmagupta's formula finds is it finds the area of this quadrilateral. It's called a cyclic quadrilateral, or a quadrilateral that is inscribed inside of a circle. So all 4 of these vertices actually touch part of the circle. And if the sides are A, B, C, and D, and again, you're looking at the semi-perimeter being the basically half of the perimeter of the quadrilateral, the area of that quadrilateral, cyclic quadrilateral, is equal to the square root of, and this is where it's a little bit different, but you can hopefully see that it's very similar to the Hero's formula. It's going to be the semi-perimeter minus the first side times the semi-perimeter minus the second side times the semi-perimeter minus the third side times the semi-perimeter minus the fourth side. It's going to be the square root of all of that. And that would be how you would find the area of a cyclic quadrilateral. I'm going to flip over to the other side right now and go through just a few problems. Okay, we're on the back side of the Hero's formula worksheet. Want to use Hero's formula to find the area of an equilateral triangle with a side of 8. You could always do, of course, s squared root 3 over 4. And you should get 64 root 3 over 4, which is 16 root 3. But for fun, if you wanted to use Hero's formula, what you can always do is find the semi-perimeter, which is going to be 3 times 8 divided by 2, right? 8 plus 8 plus 8, which is just 12. And so the formula for the area of the triangle is equal to square root of 12. And then you just do 12 minus 8 3 times, like that. And so it's going to be square root of 12 times 4 cubed, which simplifies to 16 root 3. So you get the same answer here as well as here. If you want to use Brahmagupta's formula for this one, to find the area of an inscribed quadrilateral, you would just do the semi-perimeter, add them all up, divided by 2, and then you would plug it into Brahmagupta's formula, and you're going to end up getting, so it's going to be 5 plus 7 plus 4 plus 10, all divided by 2. And then you plug it into the formula. I'm just going to tell you that the area here is going to end up being equal to 36. So you can try that on your own. It also allows you, these two formulas allow you to do problems like this. This is supposed to be the center. Fortunately, it's not drawn very well. This is 6, 8, 10 triangle. This is 5, 5, and 5. And hopefully what you can see here is you can break this down into a cyclic quadrilateral and a triangle, inscribed triangle there. And I can go ahead and do two separate, I can do a hero's formula with this guy here, and I can do a Brahmagupta with this guy. And hopefully you can see that you can get the area of the triangle, add it to the area of the quadrilateral, and you're going to ultimately end up with 56.5 when you plug it into the formulas. I'm not going to plug it into those formulas as it's not that difficult to do. I'm going to let you go ahead and do the following problems for homework. So it's going to be problems 4 through 9. Hopefully you'll be able to do that with the information that I've given you. Okay? All right. Take care.